In this video, we'll be differentiating the logarithmic function. Our theorem that we'll be using is the derivative of ln x is equal to 1 over x. Remember that the argument of ln, this argument, has to be positive. So x cannot be 0 and it cannot be negative. If we're differentiating composite functions, then this theorem can be rewritten as the derivative of ln u is equal to 1 over u times the derivative of u with respect to x. And this time u has to be greater than 0. All right, let's do an example. We're asked to find the derivative of ln cosine 7x. Well, this is a composite function, so let's let our u be the cosine of 7x. And this is a composite function, but it's a pretty simple one. The derivative of the argument is just 7, so the derivative of this expression then will be a negative sign multiplied by 7. And so now we can do the derivative of our ln, and that's going to equal 1 over cosine 7x, and then we have to multiply that by du dx, which is negative 7 sine 7x. Now let's bring our 7 in front, and then we have sine 7x over cosine 7x, and this ratio is our tangent ratio. So our derivative is negative 7 tangent 7x. Do another one. Now on this one, we're asked to find the derivative of 20x squared times ln x plus 1. So we need to use the product rule. And so I'm going to write that process. We're going to have 20x squared multiplied by the derivative of the second factor. Let me just write that. And then plus the second factor times the derivative of the first factor. Okay, the derivative of ln of some argument is, let me copy this, is 1 over the argument Now the reason that I didn't use u substitution on this is because the derivative of this argument is just 1. So it's not necessary to do u substitution there. And here I have plus ln x plus 1, and then the derivative of 20x squared is 40x. This first term is 20x squared over x plus 1, and the second one is 40x ln x plus 1. Let's do one more. Alright, we see that we have a quotient here, but since I can write these factors that are in the denominator, I can write them as factors in the numerator. I'm not going to use the quotient rule. I'm going to rewrite this. So I'm looking for the derivative with respect to x of, and the 2 in the denominator can be rewritten as 1/2, and then the x cubed in the denominator can be written as x to the negative 3, and then I have ln x. Now I still need to see this as multiplication, so I need to use the product rule. But it's still a little bit simpler than the quotient rule. So my first factor multiplied by the derivative of the second factor, 1/2 x to the negative 3 times the derivative of ln x plus, and then my second factor multiplied by the derivative of the first factor, ln x multiplied by the derivative of 1/2 x to the negative 3. This is 1 over 2x cubed, and the derivative of ln x is 1 over x. And then this one is ln x, and the derivative here is a negative 3/2, because you multiply, remember, the exponent times the coefficient. And then x to the negative 4. Be careful not to mix this up with integration, because we reduce the exponent by 1. Let's just simplify this. This first one is 1 over 2x to the 4th, and then minus, and 3 over 2 x to the 4th ln